What's the difference between alternating series test and alternating series estimation test? For alternating series test, if you have a series -1 to power n-1, bn, n starts from 1 to infinity, if these two conditions are met, if bn is decreasing, and the limit of bn as n goes to infinity is equal to 0, then you can say that the series is convergent. The alternating series estimation test, however, says if S is equal to the summation of -1 to power n-1 bn, n starts from 1, goes to infinity, where your bn are positive. And these two conditions are met. First of all, bn is decreasing. And two, the limit of bn as n goes to infinity is equal to 0, then the absolute value of S minus Sn is going to be less than equals to Bn plus 1. So why this is important? Let us take a look at this example together. In this example, I ask you to find the sum of the following series. The series -1 to power n divided by n factorial, n starts from 0, goes to infinity. So what is the behavior here? Does it satisfy the condition of bn decreasing, the limit of bn when n goes to infinity is equal to 0? Let us check the conditions for an alternating series test. So what is our bn here? Bn is equal to 1 divided by n factorial. From algebra, we know that n factorial is nothing but n times n minus 1 times n minus 2 dot 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 2 times 1. At the same time, we know that n plus 1 is more than n. So if you multiply both sides by positive numbers, n plus 1 factorial must be more than n factorial. So if you flip this, you get 1 over n plus 1 factorial less than 1 over n factorial. So as you can see, it is decreasing. Bn plus 1 is basically less than equals to Bn. You have 1 divided by n plus 1 factorial less than 1 over n factorial. So the first condition is met. What about the second condition? What's the limit of Bn when n goes to infinity? The limit of 1 divided by n factorial as n goes to infinity is 1 over infinity times infinity times infinity, which is indeed equal to 0. So the second condition also met. What is S? Let us calculate S now. S is equal to 1 over 0 factorial plus -1 over 1 factorial plus 1 over 2 factorial plus -1 over 3 factorial plus the rest of the terms, all right? Plus 1 over 4 factorial, plus negative 1 over 5 factorial, plus the rest of the terms. So you're basically calculating the addition of these terms. Or it is 1 minus 1 plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial, and so on. If you use a calculator and start calculating these numbers, you're going to see that here you end up with 0 plus a half minus 1 over 6 plus 1 over 24 minus 1 over 5 factorial, which is 120. And continue this process, right? What is our observation? If I add more terms, this is what I see. Plus 1 divided by 6 factorial plus negative 1 divided by 7 factorial plus 1 over 8 factorial plus the rest of the terms. So you get plus 1 over 6 factorial minus 1 over 7 factorial, 1 over 8 factorial plus the rest of the terms. So negative 1 over 20. If I use a calculator, give me a moment. 1 over 6 factorial, which is 1 over 720 minus 1 over 7 factorial. Let me multiply this guy by 7. I get 1 divided by 50, 40 plus the rest of the terms. So the question is, if you go back to this series, so here you have A1, and this is A2, A1, A2, you have A3, you have A4, A5, A6. We started with 0. Let me just change this to 0, then 1, then 2, then 3. Oops. This is A0, then A1, then A2, A3, A4, A sub 5, A sub 6, A sub 7, A sub 8. So what is our observation here? Take a look. If I look at B sub 7, for example, what is B sub 7? Or this A sub 7, whatever you're labeling it. A sub 7 is equal to negative 1 divided by 7 factorial, am I right? And if we ignore the negative sign, you get 1 divided by 7 factorial, which is 1 over 50, 40. Now, if I calculate all of these sums before A sub 7, what do I have? S sub 6 is equal to, just take a look at these two. I'm going to find the difference between these two values. So bear with me. So if I add all of these together, S of 6, you get a half minus 1 over 6 plus 1 over 24 minus 1 over 20 plus 1 over 720. So in that case, if you add all of these together, let me use a calculator, approximate this number, the approximation is about 0.368056. Now, if you find a difference between, this theorem says, if you find a difference between S and S sub 6, it must be less than or equals to A sub 7, which is less than This is what you calculated here, which is less than 1 divided by 50, 40, or approximately 0.002. So we get a very small error if you think about this. So this is the basics of alternating series estimation test, the difference between the actual sum and the partial sum is less than equals to bn plus 1 at some point.